Okay. So, hello everyone and welcome to Lucknow Mulesoft Meetup. This is the 10th Mulesoft Meetup for Lucknow Group, and today our topic is VPC, DLB, and Transit Gateway. So, the organizer for this meetup is Yakub, Rutuja, and myself. So, Yakub, would you like to introduce yourself?
Yeah, thanks. Thanks, Abhishek. So this is Akib Javed. So I work with Cognizant as a senior associate. So I'm working with Mulesoft for last 3 years. So I'm Mulesoft certified developer and architect. So yes, we are. I've been waiting for this session. So thank you, host, for confirming this session. Thank you. Thanks a lot. This is very informative session from your end. Over to you, Abhishek.
Yeah, thank you, Yakub. And Rutuja is not available today. So, I am this Abhishek, and I'm working as a Associate Solution Architect in Episado. I'm a MuleSoft certified developer and architect. I'm a MuleSoft mentor. Overall of 6+ years of experience and 4+ years in MuleSoft. And I'm leading the meetup group like Lucknow and Guwahati. So now I present you my our speaker, MuleSoft Ambassador Josh. So Josh, would you like to introduce yourself?
Yeah, sure. Uh, Good morning, everybody. Good afternoon. Thank you, Akif and Abhishek for inviting me. So yeah, my name is José Ramón Huerga, Jos. And yeah, I'm also working with Akif in Cognizant. And in my case, I've been working with Mulesoft, I think that in the last 3 or 4 years. I'm Mulesoft ambassador, Meetup leader of the Barcelona Meetup. I have the several certification of Mulesoft, and I'm currently working in Cognizant and at this moment implementing Mulesoft in a pharma company.
Thank you, Josh, and
Thank you, Josh.
thank you so much for taking our invite and being a speaker for this meetup. And the topic is very interesting, and I'm also looking forward to have this with you. So I will read out some safe harbor statement. So both the speaker and host are organizing this meetup in individual capacity only. We are not representing our companies here. This presentation is strictly for learning purpose only. Organizer or presenter do not hold any responsibility that same solution will work for your business requirements. This presentation is not meant for any promotional activities. Now some housekeeping activities. So we are recording this session, so we'll upload the recording in the meetup page in last in within 24 hours. So feel free to put out your question in the chat, or if you want us to unmute, then we'll do that. So we'll make it more interactive. Put out all your doubts you have. Feel free to put your question, and once the meetup is ended, you will get a feedback form. So we request you to fill up that form, because that form help us to change, to grow. So like you can choose like whatever topics you want in our next meetup, and what improvement you think we should have in our group, and we'll definitely look forward for that. So coming with the topic, Joe's, all's yours. You can present.
Okay, sure. Let me share my screen. Just a second. Mm, Okay, can you see now my screen?
Yes, yes, yes.
Okay, sure. Wait a minute. Okay, so thank you everybody for joining. In today's session, we are going to talk about Cloud Hub, and specifically how to set up Cloud Hub in a greenfield project. Okay, and a greenfield project is essentially a project in which the customer maybe has been using other middlewares such as Oracle, Azure, whatever, but is setting up MuleSoft from the beginning, okay, from scratch. Obviously, there is a lot of things that are required to implement Cloud Hub, but we are going to focus only in networking. Okay, we are going to talk about the setting up the VPCs, the load balancer, and so on. Okay, essentially we are going to follow these steps, this path during the presentation, because we believe that in order to have a good implementation of Cloud HAT, I think that the first step is to arrange and to decide a very good network design, and only when that network design is done, then we can move forward to the next steps that are essentially setting up the VPC where all the Mule workers are going to be running, and then establish the outbound communication and the inbound communications. Okay, so during the presentation, we are going to use a fictional corporation, from the Looney Tunes, that is Acme, and well, basically, we are going to assume that Acme has just become a new Mulesoft customer and wants to implement Cloud HAT. Okay, so the idea is that Acme is going to use the anypoint subscription to set up Cloud HAT, but is going to deploy in Cloud HAT APIs that need to communicate with both the on-premises data center of Acme, but maybe as Acme is a factory, is going also to communicate, for example, with the shop floors, with the factories, and also with other AWS networks that this corporation may have. Okay. Okay. So as we said before, the first thing that we need to do in a greenfield project, okay, is to design the network. Okay. Basically, before thinking, in the solution, obviously we need to gather all the requirements of the customer. Okay, because obviously they are different from one company to another. And for example, we need to know if the customer is going to expose some of the APIs of all of them to the public internet, or maybe a particular customer is going to use the APIs only for internal purposes. Okay, we need also to know before designing the network, and this is something that maybe can sound a bit strange to you, but we need to more or less know in advance how many APIs the customer is going to build. Okay, for sure, this is not this is not very good news, because we don't know typically when we implement an integration solution. Well, we don't know if we are only being able to create 50 APIs or 1,000 APIs, because we cannot predict the success of the platform, But unfortunately, in the case of MuleSoft with Cloud HAT, we need to try to do that exercise in advance and try to know more or less how many APIs we are going to create, because that's going to somehow control or dictate the sizing of the net of the Cloud HAT. Okay. Also, it's interesting also to gather in advance which are going to be the communication needs of the APIs. As I said before, we need to know if the APIs maybe they only need to communicate with third-party software as a service application, or maybe they need to communicate also with the on-premises. Okay. With all this information, with all these requirements, the idea is to think in a solution in which we need to plan how many subnets we are going to define. If we are going to put a load balancer in front of each subnet, how many domains are we going to use? For example, are we going to use a domain like api.atme.com, for example, or is going to be a different domain? Okay. And another thing that we need to discuss before trying to define the cloud hat are the network IP range that we are going to define, and which are going to be the mechanisms to connect with other networks. Okay, so in the case of ATME, once that the integration manager of ATME has joined and has met with the rest of the stakeholder, they had gathered this list of requirements. Okay, so for example, they know that the APIs of ATME has to be accessible using these 4 domains that you can see here. Okay, API-det atme.com, API-sat atme.com, and the same for UAT and production. Okay, so those are the expectation of Atme. Okay, the APIs that they are going to publish should be available using these domains. Okay. Another requirement that the integration manager of Atme has gathered is that that all the environments must be accessible from the published internet. Okay, maybe other customers only want the production environment to be accessible from the published internet, but in this case, Atme has to work, for example, with Salesforce or with Workday. Okay, and they want also during development stages in Salesforce integration to be able to invoke APIs of Atme that are still in development. Okay, so that's the reason that they need, for example, API-det atme.com to be also available from the published internet. Okay, and this customer, Atme, has also another requirement that they want to have a strict separation between the lower environments, such as dev, SAT, and UAT, to the higher environments such as production. Okay, so they need a complete different network for these environments. Another requirement is that for sure they want these APIs to interact with not only with the software as a service application, but also with other ATME networks. Okay, and after lots of conversation and lots of discussion with the development teams, they find that more or less they can expect that ATME will be creating around 200 APIs more or less. Okay, that's the estimation that they have. Okay. Okay, so with these requirements, this is the solution. This is the network diagram that Atme is going to follow to set up a Mulesoft Cloud Hat. Okay, so as we said, they need to access from internal, but also from software as a service application. Okay, and they need to interact with all the different domains that we mentioned before. Okay, with the non-production environments such as API-det, SAT, and UAT, and also to production. Okay, so the access from the Atme internal networks, okay, is going to follow this route. Okay, they are going to hit directly the dedicated load balancers. Okay, and in the case of the published internet, the Atme gets to the conclusion that it's a bit dangerous to expose directly the dedicated load balancer of Mulesoft, and they want to rely on a more powerful web application firewall such as AWS CloudFront. Okay, so the idea is that they will be hitting the CloudFront WAF, web application firewall, from the software as a service application. However, all the requests that are coming from the Acme internal networks will not need to use the CloudFront. They will go straight to the dedicated load balancers. Okay. If you recall, Acme has also the requirement to have a strict separation between non-production environments and production environments. Okay. So this translates to creating two VPCs, one for non-production on the left and another one for production on the right. Okay. an important aspect is to find in advance which are going to be the subnet range, that the IP range that are available for every VPC. Okay, we'll comment later about this sizing. Okay, but during this phase, ADME talks with the network engineers. Okay, and they get to the agreement that they are going to use the IP range of 30.2.0.0/20. Okay, we will talk later about this notation for non-production, and they are going to use this subnet for production. Okay, and finally, to fill the requirement to communicate with other internal network of ADME, they are going to use a AWS Transit Gateway. Okay, so this is more or less the outcome of this first phase, that is the network design. Okay.
Josh, sorry to interrupt. I have one question over here, like from Harsh. Would you like to take it now?
Yeah, sure. Okay,
Okay.
let me.
So he's asking, while creating the initial design, should we consider unforeseen requirement in terms of in terms of load and usage as well?
Yeah, yeah, for sure, because especially in the sizing. In this case, if we know, for example, that these 200 APIs of ADME, they are going to have some of them, imagine a 25%, for example, of them are going to have a very high traffic. Obviously, we will need to create replicas of those workers, so that will affect to the sizing of the network. Okay, because the problem here is that, and this is not really a problem of Mulesoft. It's more like a problem of AWS. No, is that once that you define a VPC, you cannot change that in the future. Okay, so for example, if you define this subnet with a sizing of /21, if unfortunately in the future you need to create more APIs, and all of those APIs you need, for example, to have like 3 replicas, 4 replicas, then you have a problem, no? Because maybe you will need to create in the future a second VPC, or maybe during a weekend, no, try to remove this VPC, create a new one, large, a bit large, and migrate, no. So yeah, so definitely you need to take into consideration the load requirements in this phase. Yeah, good point. Okay, any other
Thank,
question?
thank you, Josh. Hers, I hope that is clear. No, that was the only question till now. Anyone, any question?
So I have one question. So let's
Yeah.
say how we define the number of VPCs we need, Jos?
Yeah. For example, well, keep in mind that by default, when you buy the base subscription, you are entitled only to use two VPCs. Okay, so that's the reason that most Mulesoft customers are using two VPCs. Okay, however, there are multiple cases in which, for example, a customer might need, for example, two VPCs for production. Okay, for example, imagine that this customer is like, for example, an e-commerce, and they want to have all the APIs that are going to be accessed from the public internet in a VPC, and maybe they want to have in a second VPC the APIs that are more related, for example, with the interest with interaction with the ERP. Okay, so in that case, maybe it will be a good idea to have two VPCs. There is also another detail, no? The bigger that we create a VPC, the more problems that we are going to have later with the networking when it comes to open firewall ports. Okay, so maybe that's another reason in which other customers might have the requirement to create, for example, 3 VPCs, no, and one of them create with a very low number of hosts, and to make sure that they can firewall that VPC, and the network team, no, the owners, for example, of the F5 firewall, are not going to pose a lot of problems. Okay, So yeah, it varies it's different from customer to customer.
Thank you, Josh. Again, we have two more questions. Would you like? So,
Yeah,
like Gajanand is asking, how to define the TGW?
yeah.
Is it per each VPC?
Okay, we are going to comment later about the transit gateway. So yeah,
Okay,
so later we are going
okay.
to comment that.
One more from Harsh. Is the customer charged for unused VPC as well?
Yeah, yeah. In this case, for example, no, ADME. Imagine that ADME is paying to Mulesoft, I don't know, 200,000 euros per year. Yeah, it's the first six months, for example, they are only working in the non-production VPC, but the production VPC is not even defined. Yeah, they are going to keep on paying the same amount per year. It keep at the end in the base subscription is something that you are going to pay every year, no matter if you use that VPC or not. Okay, so yes, you need to pay for that also.
So
So
that
it's a good idea to use it. Yeah,
yeah, so that 2 VPC is already bundled with our gold subscription, right? So if you use it or not, we have to pay it anyway.
yeah. You are not going to get a discount, no,
Yes,
if
yes,
you don't use any VPC. Okay,
yeah,
or maybe if you talk with the account manager, you can go to an agreement. Yeah.
yeah.
Yeah, but it's very it's very difficult to find an scenario in which you are not going to use the two VPCs, no, because for sure you are going to be developing the APIs or the batch processes, so you need a development environment, and it's very common that once that you go to production, you will want to use a separate network.
Yeah.
Okay,
Okay. Thanks, Jos.
okay. Okay, so once that we had defined this diagram, and we had talked with all the different stakeholders, it's time to execute the first task, that is to set up the VPCs. Okay, so as we had mentioned before, uh, any point virtual private cloud VPC is nothing more than AWS VPCs. Okay, so essentially, a VPC is a is an artifact, is a mechanism that enables you to launch Mule applications. Okay, and the idea is that those Mule applications is going to be living in a virtual network. Okay, this virtual network, as you have seen, is very similar to a traditional network. You had the IP range, you had the firewalls, you had rules to communicate with the outside. Okay, and the good news is that you don't need to take care of the infrastructure. You don't need to buy a hardware device for the load balancer, another hardware device for the firewall, because it's something that AWS takes care. Okay, the VPCs are totally isolated from other virtual networks. So if you want to communicate one worker that is in a VPC with another worker that is in a second VPC, it's not possible unless, obviously, you define rules in the DLB and you allow that traffic. Okay. Once you define a VPC, that definition is going to spawn all the 3 or 4 availability zones that are typically in every AWS region. Okay. Uh, as we said before, typically we are going to have two 20 point VPCs per subscription. Okay, and we can associate a lot of environments to the same VPC. Okay, you don't need only to think in terms of development, SAT or UAT, because keep in mind that in MuleSoft you have also the concept of business groups. Okay, so a big corporation may have a separation of business groups. For example, may have a business group only for finance APIs, another business group only for commercial APIs. Okay, and all of those business groups may have also development, SAT, UAT, and production environments. So you can put together all the development environments or the SCTM environments of the different business groups together in the same VPC. Okay, so you don't need a VPC for the business group of finance and another VPC for the business group of commercial. Okay, you can reuse that. Okay, the idea is that maybe, and you were asking that before, maybe in another customer they want to have also a total separation of UAT. So in that case, maybe it could be a good idea to buy to Mulesoft a new VPC only for UAT. Okay, so in that case, you will have a strict isolation of that environment. Okay, you can, when you define the VPC, you have also to select which is the Amazon region that you want to use. Okay, so again, imagine that ASME in the future wants to operate in other parts of the world. So in that case, maybe that will be another good idea, no, to buy more VPCs, no, for example, to deploy APIs in a region of Singapore, for example, no. So that will be another, you know, uh, another point, no, to buy more VPCs. Okay. Okay, so, and as you can see on the diagram on the right, no, the idea is that all the APIs will be in those VPC acting as a separate container. Okay, totally isolated from one to the others. Okay. We mentioned before that once that you define a VPC and you establish the sizing, is something that you cannot change. Okay. The idea is that the sizing of the size of the VPC is described using a notation that is CIDR. Okay, that stands as classless interdomain routine. Okay, so essentially, as you can see on the table on the right, there is a lot of there is a lot of size of networks. Okay. And for example, you define a network that has a size of /24, you are allowed to start in that network only 256 hosts. Okay. In the case of ADME, if you recall, ADME was planning to create around 200 APIs. Okay, so that's the reason that they want to go for production with a CIDR of /21, and for non-production with a CIDR that is bigger, that is /20. Okay, so how to get to these numbers? No, essentially there is a rule of thumb in which you typically multiply by 10 the number of APIs that you are expecting to create. Okay, and the reason that you are multiplying by 10 is essentially because you may have for example 4 replicas, okay, of the same API that is going to be typically on distinct availability zones. Okay, there is also as you know, when you are deploying a new version of a Mule application, it's a blue-green deployment, no, in which Mulesoft, when you are deploying the new version, is going to bring it down in a new worker, but the worker that is executing the previous version is still working, no, it's still up and running, and it will only be shut down when the new version is bring up. Okay, so in a in an scenario in which you need, for example, to deploy a new version to all the different workers, no, you may end having the double of workers that you will have in a normal situation. Okay, so that's the reason that that you get to the 10 times. Okay, because it's four times for the different availability zones, 2 times for this deployment with zero downtime, and also a few IPs that are reserved for infrastructure. Okay, so should you go with a big number or not? well, it depends, no? If you go with a very big number, okay, and you can afford that, it's a good idea, no? Because in the event, no, that you end having a lot of APIs and you have a lot of high availability requirements, then obviously with a very big VPC, you are not going to suffer those problems. But however, there is a problem. No, you define always very big networks. No, that is that later is going to be very complex for you. To talk with the network guys, no, and convince these people to open their ports, for example, to an slash 19th subnet, no, because they are going to tell you that you are crazy, no, that you want to whitelist 8,000 hosts, no, and that's a security risk. Okay. So as you can see, there is a trade-off, no, between defining a sizing that is not going to pose problems with the networking, and also is not going to go to pose problems in the case that in the future you are having a lot of APIs. Okay, so this topic is not. I can tell you that it's not very easy. Okay. Also, you will need to use or to be able to resolve private domains from this VPC, because imagine, no, in the case of ATME, you want to create an API on top of SAP. So probably SAP is going to be accessible in a domain such as sap.atme.com. Okay, so in that case, you need to specify in the VPC which are your DNS that you are going to do use in the Mule APIs to solve the internal DNS. Okay, you can specify two servers. Okay, and essentially Mulesoft will use them in a round robin way. No, so it will be asking to one of the DNS to resolve a domain, and probably for the next request is going to use the second one. Okay, so with all this information, how this translates to ATME. Okay, so this is the runtime manager of ATME. Okay, as you can see here. Okay, and these are the two VPCs that we had defined for ATME. Okay, this is the production and the non-production. Both of them are in this region in North Virginia. Okay, and if you recall, this is the CIDRs that we define in the network diagram. Okay, as you can see, production is smaller. It's only a 21 CIDR, and non-production is a 20 CIDR, because you will have more environments in non-production. Okay. If you click in the non-production VPC, you will find this page, no, with the. I'm going to make it a bit bigger. Okay, sorry. Okay. So essentially, in the non-production VPC, you will see the CIDR, okay, the load balancer that are associated. That we will see that later in more slides, okay. And another thing that we mentioned before, the internal DNS. Okay, so this internal DNS, as I said, is the ones that the Mule workers are going to use in the ATME APIs to resolve other domains of ATME. Okay, and these are the two DNS that they are going to use. Okay. And essentially, this is all the configuration. Okay, if we come back to the main menu and we inspect the production VPC, the configuration is going to be very similar. Okay, and the only different is that the CIDR is the ones that belongs to production. Okay, and the same with the DNS. Okay, obviously, in another customer that has different DNS for production and non-production, these IPs will be different. Okay. Okay.
So
So any
yeah,
questions so far? Yeah.
so you have said the cider size should be around into 10. So is that a very good number, or we can go ahead with some lower numbers also?
When you multiply by 10, you are covering with the with the load numbers and the highest availability, because keep in mind that one of the reasons that you multiply by 10 is also to cover the case in which you're going to have like 4 replicas, no, each of them on the different availability zones. Okay, so yeah, so in that case we are including in this sizing also the load requirements.
Okay, okay.
Mhm. Okay. Okay. Any questions so far regarding the VPCs? Okay. So once that we have defined the VPC, the second step is to make possible, no, that these Mule applications are going to be able to communicate with the outbound, no, with other systems. Okay. So the reason for that is that obviously, no, most of the APIs that we're going to create, they need to interact with other backend systems. Okay. So we for sure we can do a communication directly to the internet, no. So we can create, for example, an API in ATME that will communicate, for example, with Workday or with any other software as a service application. But it's common, no, that we will need to communicate also with other VPCs of the customer and also with on-premises networks. Okay. So there are different mechanisms, okay, and in this session we're going to focus in AWS Transit Gateway, okay. So the different alternatives that we had is the classical VPN, the new Transit Gateway attachment, the VPC period, and the AWS Direct Connect, okay. So very quick, just to refresh the concept. This is one of the most classical, no, that is a standard VPN, in which essentially what we are doing is to define a tunnel, no. We have, I think that we have up to two tunnels, no, per VPN, and in this case, basically the customer will allow to CloudHub, no, to set up a VPN connection. Okay. Another one that is also very, very classic is if the customer is using also AWS, then it's possible to set up a peering connection, okay, between two VPCs. Also, it's possible to use a direct connect to communicate directly with the on-premises. Okay, so these are the three options that were available until 2022, 2020, 2021. Sorry. But later last year, Mulesoft released this other approach that is based on AWS Transit Gateway attachment. Okay, so in this case, the main difference is that we don't need to create a lot of VPC peering connection or VPNs. So we just need a connection to the Transit Gateway, and then from the Transit Gateway, we are going to be able to hit every other VPCs that this customer may be using, and also the on-premises. Okay, so essentially the idea is to use AWS Transit Gateway instead of VPC peerings, just for one reason. No, when you are doing VPC peering, you can only peer two VPCs. Okay, so for example, if you create a VPC, but you need to connect to two other VPCs and to a VPN, you need to establish a VPC peering between the Mule VPC and for example, the X VPC, the double VPC, and so on, and also with the on-premises, no, which translates to a lot of point-to-point connection between networks. Okay. However, when using AWS Transit Gateway attachment, the solution, as you can see, is simple. No, you only need to send the traffic to the AWS Transit Gateway, and that one will take care of routing that to other VPCs or other networks. Okay, so I think that this was a huge improvement in CloudHub last year. Okay, And and with this one, I think that the connectivity things gets very, very simplified. Okay, so that's the way, to be able, to communicate with the backends. But it's not only that, no. Once that you are able to hit the different backends of, in this case of ATME, obviously you need also to talk with the network team to set out firewall rules. Okay, and as we have been mentioned before, there are, there is a straightforward approach, that is to whitelist the full CIDR of the Mule VPC in the firewalls of the company. But probably if the CIDR is not very big, no, maybe it's only contains 500 hosts, or maybe 1,000. Probably, the network team is going to open the ports to the full CIDR. But if you are using large CIDRs that may contain 4,000 APIs, for sure, the firewall team is going to, they are not going to like the idea to firewall or to whitelist all the workers of the Mule VPC to the internal networks. Okay, so there is a good news, no? There is an alternative, that is to use full qualified domain names. No? So instead of asking to the network team to whitelist everything, you can go with a fine-grained approach, and it's possible to, given any Mule worker, you can find which is the IP of that worker. Okay, just by looking at the name of the worker. So if the firewall of the customer is powerful and has the ability to whitelist using full qualifying domain names, then I think that that's a good news, no? Because then the firewall team can just set up an explicit rule that will only allow a specific worker of Mulesoft to hit one backend. Okay. So this is something that you need to take into consideration, okay? Because it's free to define a huge VPC in Mulesoft, but you can get into problems later when you are trying to hit the backends. Okay, so it's definitely something that you need to bear in mind. Okay. Okay, so how to do this in Mulesoft, no? So essentially, in the case of Athme, as you can see on the screen, in the runtime manager, there are different options in the left, no? Such as defining the VPC that we did before, the VPNs, and also define the transit gateway. Okay. Probably you are missing the other alternatives that we mentioned before, like the VPC peering and the direct connect. And the reason for that is that they are not available as an automated or self-service operation in the runtime manager. No, it's something that you need to request by writing an Excel to MuleSoft. Okay. So when you click on Add Transit Gateway, essentially you are going to get this screen, no, in which MuleSoft is explaining, no, that to send an attachment, an AWS Transit Gateway attachment to ATME, you need to, you need to specify, no, which is the region, no. So in that case, what we are doing is attaching, no, to an existing transit gateway of ATME, and in this case, that transit gateway is also in this region. Okay. So once that you do this, then essentially MuleSoft is generating by you this ID, that is the account ID of in this case of the PPC of MuleSoft. Okay. And then you need to contact with the network team of ATME. Okay. So they are going to allow MuleSoft to connect to the transit gateway of ATME. Okay. Once that you do that, okay, you get the transit gateway associated to in this case to MuleSoft. Okay. And if you click in the transit gateway, okay, you will see something like this. Okay. I'm going to make it a bit bigger so you get an idea. Okay. Sorry. Oh, sorry, but the
No,
PowerPoint
no
just closed.
worries. No worries.
Okay.
Yeah.
Yeah, I think that all this tuning and so on has broken the PowerPoint. Sorry.
Sure, sure, sure. Just a tip, guys. Like if you want to full screen, you want to do full screen for your screen to make it more visible. You can just right click on your screen, show all controls, and to the left bottom corner you will see an option to full screen your screen.
Yeah. Okay. So here we go again. Okay. Uh, I will try to zoom in again. Okay, so basically, this is the configuration of the transit gateway of TATME. Okay, so we are pointing to a transit gateway that is in this case in North Virginia. Okay, and then typically what we're going to do is to generate two attachments. Okay, one that we are going to use with the non-production VPC. Okay, and another one that we are going to use with the production VPC. Okay, so basically the main concept is this, no? The transit gateway is already property of ASME. Okay, so we are just connecting the two VPCs of Mulesoft to ATME. Okay, so that's the concept. Okay, essentially we are getting a transit gateway attachment for non-production and another one for production. Okay, and once that the attachment is associated to the VPCs, we can start sending traffic through the transit gateway. Okay, and we will have essentially three different alternatives. We can do local traffic that is going to be inside the VPC. We can generate internet traffic. Okay, so we are going to use the internet gateway. And the most important, if we want to connect or to send to communicate with any other subnet or SATME, we are going to use this transit gateway. Okay, so basically, the idea is to associate the attachment to the VPCs and then add as many routes as requires. Okay, if we click on ADD route, essentially we are going to get this dialog. Okay, in which what we are saying is, okay, I want this VPC to communicate with this other subnet, okay, and I want to use a transit gateway route. Okay, so once that you have defined all these routes, then essentially any Mule worker will be able to communicate with other networks or TATME by using the transit gateway. Okay, so I don't know if you have any question about this.
Yeah, one question we have, Josh. This is from Bipin. Does TGW comes with an additional cost compared to other connectivity options?
No, I'm not aware of that. I think that maybe I don't have the exact information, but I think that is also included with the base subscription. Okay, I'm not 100 sure of that, but I have no I don't remember to have seen an special add-on for that. I think that you have a base subscription, check it out, but probably you are going to see the option to use the transit gateway option. Yeah.
Okay.
Mhm.
Yep.
And
No
definitely
other.
try yeah, definitely try to use that because if you only need, for example, to communicate, for example, ADME with another VPC, the VPC peering is no is a good idea. Okay. The problem is when you need to communicate with 3, 4 other VPCs and a couple of on-premises subnet. No, in that case, definitely transit gateway is a very good idea because with just one operation, and as you can see, it's very simple. No, it's just to generate this number and and communicate with your network team, and then in hours you get the transit gateway associated. No, it's something that is very quick.
Okay, we have
Yeah.
one question from Valerio. He's asking,
Okay.
one quick question is is the routing also faster other than easier to manage?
Yeah, in that case, probably I'm not a network expert, so probably it's not going to be faster. I mean, because at the end, a VPC peering, between two VPCs, I'm totally sure that it's also a very fast solution, no? So I think that when we can see that here, I think that when AWS and later Mulesoft introduced this concept, it was not only for terms of the speed. No, I think that is more in terms of manageability. No, because at the end, what you are doing with the transit gateway is like having a hub, no, a networking hub. No, so probably when you introduce a hub, no, obviously you have another jump in the network, so probably it's not going to be faster. No, maybe it will be, I don't know, a few milliseconds. No, but definitely is more in terms of flexibility. No, but keep in mind that I'm not an expert, no, in AWS. No, it's just my intuition. Okay.
Yeah. Thanks, Josh.
Okay.
So we have two more.
Oh.
Would you like to take it now or a little bit later?
Yeah, no, we
Okay.
can yeah.
So Nilesh is asking two questions from him. Is Transit Gateway only available with AWS or with other cloud too? If
Eh,
yes, then how to connect with other cloud if don't use AWS?
okay. And no, definitely no. This is a thing of AWS. Okay, the transit gateway is only a concept of AWS. No,
Okay.
yeah. The question now is, for example, in case that admin needs to communicate, for example, with Azure, no, or with Google Cloud. In that case, I think that maybe you will have to go with the traditional VPN. You know. Uh, I'm not 100 sure of that. No, I mean, I'm sure that you are not going to be able not to use this unless maybe that could be, yeah, maybe no, sorry. I think that maybe you can still keep on using AWS Transit Gateway, but then the solution will be probably that AWS Transit Gateway will be connecting with Azure. Okay, I think that will be the best solution. Okay, keep in mind that also it depends if this customer is also using AWS Transit Gateway. Okay, if this is a customer, for example, in the case of Azme, they are very big customer of Amazon. No, so in that case, they have already AWS. So for them, it's very simple to just attach Mulesoft to the same transit gateway that maybe they have been using successfully for the last year. Okay, so yeah, I think that this depends no heavily if the customer is already an AWS customer. Yeah.
Okay. One question from Harsh: is VPC multi-tenant service?
Sorry. So the
Yeah, I
question
will
is,
repeat.
yeah,
Is VPC multi-tenant service?
no, yeah, you mean, okay? So this is for the VPC. No. The VPC is only for you. Okay. Let me come back. No. It's totally private for you. I mean, in this case, Atme. If you look at these two VPCs, they are not multi-tenant. I mean, these VPCs are property of Mulesoft, but the only customer that is entitled to use this VPC is Atme. Okay, so and definitely this is a good news, no? Because you have the warranty that only Atme is going to be able to manage and to interact with these VPCs. Okay, so yeah, it's not multi-tenant.
Yeah. Thanks for that, Josh.
Okay,
No more question.
okay, sure. Okay, so let me come back. Okay, so still in the outbound traffic phase, I think that there is something that is also crucial for you to be aware of that. Okay, keep in mind that maybe we are in this step, no, and we have set up the transit gateway and the attachment. Okay, but we need to test the connection. Okay, we want to make sure that the APIs of Atme are capable of hitting other servers. Okay, So how to do that? No, for sure you can create a simple test API, okay, and use that to verify all the connectivities, okay. But there is another alternative, okay, that is to use one application that that Mulesoft has published in GitHub, okay, that is the NetTools API, okay. The reason for this is that although the console of Mulesoft Cloud Hat is very powerful, but the bad news is that today is not providing a diagnosis tool. Okay, you can create a lot of things, but today there is not a diagnosis tool. Okay, so the idea is that is to install a specific Mule application in the VPC to be able to quickly test all the connections. Okay, there is a version specific when you are using a DLB. Okay, so you need to be careful with that. Okay, and another thing that is important is that this testing application that you are going to see is a bit dangerous, no, because it allows you to do a lot of things. So my recommendation is to install this mirror application, but try to, you know, once that you are done with the setup, try to disable that application or directly remove that, because it can be a bit dangerous. Okay, so this is the tool. Okay, essentially the steps is to download the code from GitHub and then upload in the VPC. Okay, so for example, you have this tool, no, that is a pin, a classical one. Okay, but for example, you can do also a trace route. Okay, so imagine that you have set up the AWS Transit Gateway and you want to communicate, for example, with, I don't know, with PeopleSoft, no, with the PeopleSoft of Acme. Okay, so in this case, you can use the trace route to try to find which is the, you know, the different network hops that you are doing when trying to hit PeopleSoft, no, for example. And you have also another interesting tool that is very similar to Telnet, no? That is the socket. You can specify any IP and any port, and it will try to check if VPC is capable of hitting that port or that IP. And you have also another one that is very powerful, that is curl. No? With curl, you can, you know, you can do a get operation with any URL. Okay. There are a few options, no? You have also the ability to test DNS, to test certificates, okay? So, as you can see, once that you have established for example, the transit gateway, my recommendation is to install this application and use that application just to try to ping, to connect to all the ports that you need in your system, okay? And if for some reason you are unable to hit a particular port, there are chances that you need to talk with the firewall team, okay, and start defining the rules that we defined in the previous slides, okay. So definitely this is a very interesting tool to install in Mulesoft, but please remove that as soon as possible. Okay, you don't want to a hacker, no, to go to a specific URL and have all these different tools, you know, to send traffic to any IP. Okay, so take care also with that. Okay. Okay. Any questions of this?
I don't see any question in the chat.
Okay. Okay. It's not the first time that I see, you know, development team that creates a simple API to test the connection with a backend. Okay. So with this tool, you don't need to do that. Okay, I recommend you to use this tool. Okay. Okay. So this is for the outbound traffic. Okay. Finally, we need to take care of the inbound traffic. Okay. Essentially, if you are only doing batch processes, then obviously this is not an issue for you. But if you are using Mulesoft to create, for example, APIs, then obviously you need to be able to accept HTTP requests. Okay, you have essentially two alternatives. You can go with the shared load balancer, or you can go with the dedicated load balancer. Okay, the shared load balancer is the one that, especially when you are playing, no, with a personal anypoint connection, is the one that is there. Okay, And the dedicated load balancer is I think that is a much more powerful alternative, okay? Because with the dedicated load balancer, you have a better performance because the shared load balancer has a rate limit. Okay, it's a very big rate limit, but definitely there is a rate limit. In the case of the dedicated load balancer, you can create as many replicas of the load balancer as you want. I think that you can. I have seen even four workers only for the DLB, so you have a lot of throughput. You can create vanity domains. If you recall, ASME wants to expose the API, like for example, api.atme.com. Okay, so in that case, you will need the dedicated load balancer to set up these specific domains. Okay, with the DLB, you can do something that is crucial, that is whitelist the consuming application. We are going to see that later. And you have a lot of flexibility to define URL paths using worker rules, okay? So, you know, the combination of the vanity domains and the flexibility to define URL paths, you know, is quite interesting because you can use those to create exactly the domain and the path that you want for your APIs, no? And finally, you can use also mutual TLS. So you can give to your consumer application a certificate, and they will need to use that certificate to start any traffic with the DLB. Okay. Okay. So essentially, with the DLB, the idea is to create any number of SSL endpoints. Okay. Essentially, an SSL endpoint is going to be all the different URLs that you are going to use to hit your DLB. Okay. So, for example, in the case of ASME, you recall they need 4 different URLs. Okay, the one for production, development, SAT, and UAT. Okay, so this translates to 4 SSL endpoints. One of the endpoints is going to be in the DLB of production, and the other one is going to be in the DLB of non-production. Okay, because the DLBs are associated to the VPCs. So typically, if you have 2 VPCs, you are going to have the ability to bring up a DLB per VPC. Okay. And to define these domains, you need to create a certificate. So typically, you need to talk with the security team of your company, in this case of AFME, to generate the public and the private key, no, the certificates that belongs to these domains, no, or subdomains. It's possible also to define as many alias, no, or suggest alternative names as you need. Okay, so for example, imagine that for production you need, for example, api.atme.com, but maybe I don't know, you need something like api-public atme.com, no, in case that I don't know that you want to have a separate URL for the public internet. Okay, so you can do that using the same certificate. And another thing that is very important, that you can define mapping rules. Okay, so probably you are aware that the Mule workers, they need a globally unique name, no? So it's also common, no, to use, for example, the ticket, no, the stock marker, no, to as a prefix for every single worker name, no. So you will have more chances that no other company has used the same worker. Okay. In the case of ADME, they are going to be following this convention. Okay. So the idea is that every time that you deploy an API in ADME, you are going to use this naming convention, no? Like ADME hyphen, a domain that can be something like financial, commercial, and so on. The environment, like development, SAT, the name of the application, and the version, because maybe for some specific Mule application, you need to have the version 1 and the version 2 running in parallel for years, no? So the idea is that you have to define naming conventions to guarantee that the workers have a globally unique name, but using mapping rules, you can map those URLs or these worker names to a specific URL. Okay. So for example, in this case, we are able to control the subdomain of ADME like API or API dev or whatever. And then using mapping rules, we can say, for example, that this part of the worker name, for example, domain, will be in this part of the as a path parameter, okay? And then after that, for example, we can define that we need the application name and the version, okay? So that's something that is very flexible because you can rearrange all these fragments of the worker name as you wish, okay? So definitely something that is very important, and you can do that with the DLB. It's not something that you can do with the standard shared load balancer, okay? Another thing that is very important with the DLB is that you can also block the traffic to specific IPs, or allow the traffic also to specific IPs or subnets. Okay, so this is something that you will be doing in the DLB. There is a limit that is not very high. It's only 240 rules. Okay, and by default, you need to be careful because the DLB is including a rule that is very generic. No, is essentially to allow the traffic from anywhere. Okay, but if you remove that rule, you can create as many rules as you need. So you will be blocking the traffic to unknown consumers. Okay. Uh, Today it's important not to create a lot of rules at the same time, no, because you know, today this process needs to interact with AWS to create security groups, and we have found sometimes problems. No, if you try to create 100 allow lists in 1 minute, no, probably you are going to get some problems. Okay, but if you do that, you know, with some delay, it will work properly. Okay, so. Coming back to Atme, okay, this is the DLB that we have created for Atme, okay. So basically, I'm going to make it also a bit bigger. Last time it crashed. I thought, okay. So these are the DLBs that is going to use Atme. Okay, so we have the load balancer for non-production and the load balancer for production. Okay, as you can see here, and in this case, no, they has already been started. Okay, so if we click in the non-production DLB, okay, we are going to see this screen. Also, let me make it a bit bigger. So basically, we have a couple of IPs that are dynamic, okay, and are associated with the DLB. Okay, so today, if somebody wants to access to the DLB on non-production, no, or Atme, they can try to hit this URL. Okay, this is the main certificate that we are going to use for non-production. That is the certificate for development. Okay, we had created 2 workers for this DLB. Okay, but if we have more traffic, we can increase that. Okay, we can have as too many as, I think that is 4 or 5. I don't recall now. There are a few parameters that, as you can see here, that essentially is if you want to have like an automatic redirect, no, you try to hit the DLB using HTTP instead of HTTPS. Okay, you need to be careful with this, because if you select something like redirect, then instead of 240 allow lists, you are going to get only 120. Okay, so be careful with that. Okay, and finally, this is the list of certificates that we have installed in this DLB. Okay, maybe another solution will be, instead of defining as many certificates, okay, maybe we will have created a wildcard certificate. Okay, so maybe that could be another alternative. Okay, but essentially, we have defined in the DLB several certificates. Okay, typically what we are doing is to define a certificate per environment, such as dev, SAT, UAT. It's also recommended to create another certificate for the internal traffic, because you follow the API-led architecture, no, this thing of the experience, process, and system layers. Probably you are going to have also traffic between experience APIs and process APIs, no. So in that case, it's a good idea to use a separate domain. In this case, the internal domain. okay, just to map directly to private IPs instead of the DLB, okay? And depending on the scenario, for example, in this case, we are going to use a web application firewall, then we are going to create also a certificate only for the web application firewall, okay? So this is a lot of work because you need to create all these certificates, you need to apply that in the DLB, and not only that, for every DLB, I'm going to come back to this later, you need to, you need to not only to install the public key and the private key in the DLB, but you will have also to define which are going to be the mapping rules, okay? This is the mapping rules that are specific for ATME. And if you recall, I'm going to make it a bit bigger. We said that we want to map in the path parameters the name of the ATME workers, okay? So you recall, we wanted to have like a fixed prefix that is ATME, later the domain, later the environment, and then the application name and the version, okay? So once that what we are doing is mapping the path parameters, no, like a slash domain, to the specific substring in a Mule worker, okay? So typically, you are going to do that per every single certificate, okay? So basically, once that you define that you want to create a new SSL endpoint, then you need to specify which is the public key and the private key. And as I said before, you need to set out also the worker rules, okay? And another thing that is also interesting, as we said before, is how to block the traffic to a specific IPs, okay? So if we maintain only this rule, this is going to be a bit dangerous, no? Because 000 essentially is allowing the traffic to every single IP in the world, okay? So the idea is to try to block the traffic, no? And to specify here only the subnets that you know that are entitled to consume your APIs, okay? So this is for non-production, and if we click in the if we click in the production, okay, it's going to be very similar, okay? This is the DLB for production has a separate domain name, this one, okay? Again, it will have a couple of IPs. It will have this certificate, as you can see, is specific for production. It does not contain any reference to the lower environments such as dev, SAT, and so on. Okay, and in this case, obviously, it's simple, no? Because in production you don't have the UAT, SAT, or development environment. You only have one environment that is production. Okay, so we will be having only, in this case, three certificates, okay? And also an allow list, okay, that as you recall is limit only to 240 subnets, okay? As I said before, you can create new CIDRs, okay? But today you need to be a bit careful, no? Because if you try to create, in the same session, like 15 or 20, today you are going to get an error, okay? So until Mulesoft fix that part, you need to be careful with that, okay? And this is again, no, the configuration for the production certificate. This is the mapping rules for production. In this case, in ATME, there is a small difference between other environments. That is that we are not using the environment name. We are not putting the environment name in the name of the worker. Okay, so in the case of dev, the keyword dev was in the middle of the worker name. In the case of production, we don't want the environment name. So that's the reason that the mapping rules for production is a bit different. Okay. Okay. So well, I think that is a lot of information. I hope that is clear. There is a question for that.
So we have a couple of questions, Josh. So first question is from Soumya. So what is difference between shared load balancer and dedicated load balancer?
Okay. Typically, you're going to see that very clear here in this screen. Okay. So you can create VPCs for sure, and you can use a shared load balancer. Okay, a shared load balancer is something automatic in the sense that if you publish, for example, today the API hello world, okay, in these VPCs, then automatically you are going to have a domain that is something like hello world dot, I think that is cloudhat.io, whatever, no? And that domain is only for you, okay? But that domain is going to be executed by a shared load balancer. This shared load balancer is essentially is a software that is maintained by Mulesoft, but the same instance is for the whole world. Okay, so you can imagine, no, that if today Mulesoft has, I don't know, 2,000 customers in the world. If you use the shared load balancer, you are going to be using as a fraction of that big load balancer that is being used by other customers in the world. Okay, so and as we said before, it's totally okay to use the shared load balancer, okay, because it has a good performance. But if you need any of these, if you have any of these requirements, you need to go with the dedicated load balancer. Okay, the dedicated load balancer is a process that is only for you. Okay, it's in your VPC. Okay, and it's not possible for other customer to use the dedicated load balancer. And this is something that is only for you. It has a better performance because if you recall, we can create more workers. You can define all the vanity domains. Okay, for example, it's okay for you to have that your hello world API is something like hello world.cloudhat.io, then that's great. But for example, for admin, they don't like that. No, they want the hello world application to be something like api.admin.com/api/hello world. That's the requirement for Acme. No? So in that case, if you have a vanity domain requirement like Acme has, you need to go with the DLB. And this thing of the, as we have mentioned, of the whitelisting is also important. No, with the shared load balancer, everybody can hit that API. However, in the case of Acme, they don't want that. No, they want to be able to specify whitelisting, as you can see here. Okay, and they want to make sure that only these few IPs are capable of hitting the APIs of ASME. Okay, so that's again another thing that with the shared load balancer is not possible today. Okay, okay.
Okay.
Next question.
Yeah. So next question is from Bipin. So he's asking, where is the FQDN defined? For example, the acme-dev.com.
Okay, it's here. It's not something that you specifically that you enter the name. Okay, but for example, these are the fully qualified domain names. Okay, in this case of non-production. And to define that, essentially what you do is to click on add a new certificate. Okay, so once that you add a new certificate, the fully qualified domain name is inside this file. Okay, as you can see here in this screen, there is no a field in which you can define the domain name. Okay, it's something that is not possible. But what you do instead is to upload a couple of files in PNM format, and in those files are the fully qualified domain name. And not only that, it's also possible to create these files and insert in them several subject alternative names, okay, like this one. Okay, so it's not like a specific field, it's inside the certificates.
Okay. So last question is from Harsh. So DLB workers are shareable or they are separate?
I think that they're separate. I think I'm not 100 sure of that, but I think that when they say worker, okay, I think that they are referring only to the number of processes that are associated with the DLB. But I don't know, I think that they don't compete with the API workers. The only thing that for sure they are competing is with the APs. Okay, so if you choose to have 4 workers, then each worker is going to have a different IP address. So obviously you have a very small VPC and you have a lot of APIs and you define a lot of workers for the DLB, then maybe yes, you are going to have a problem for that. Okay, but I think that is just an unfortunate name. I mean, it's worker, and yes, I agree with you, no, that maybe a lot of people are going to think that this is the same that the Mule workers. Yeah.
Okay, we have no more questions. We can quickly
Okay.
finish our session.
Yes. Yes. So this is just to finish. It's almost done because it's going to be only a few slides. In this case, in the case of ADME, they want to add some extra protection in the inbound traffic. Okay, so that's the reason that we are going to go with the web application firewall. Okay, so typically, if you recall, ADME has chosen to go with Cloud Hat. Okay, if they had chosen to go with Mulesoft runtime fabric, then they will have the ability, or they will be entitled to use Mulesoft anypoint security. However, today, if you go with Cloud Hat, you cannot use Mulesoft anypoint security. Okay, so this is bad news for ADME because they wanted to have a WAF, a web application firewall, but that's not possible, no? Because it's not possible to set up the Mulesoft anypoint security with Cloud Hat. Okay, so that's the reason that that in this case ADME wants to use, in this case, the web application firewall of AWS. Okay, so the web application firewall of AWS is living inside AWS CloudFront. Okay, so essentially, what is going to do ADME is to create an instance of AWS CloudFront. Okay, so typically, what we are going to do is to configure this instance of AWS CloudFront to forward all the headers to the Mules.dlb, which is something that is very crucial, especially if we want to maintain all the headers related with authentication and with cores. Okay, and there is another thing that is important, and this CloudFront is a global service that is provided across the world. So there are more than 100 servers that are in the CloudFront service of AWS. So ADME needs to whitelist all these IPs or subnets of CloudFront in the DLB. Okay. And another thing that is going to use ADME is to set up a custom header from the AWS CloudFront to make sure that that maybe another request of another customer of AWS CloudFront is not being able to hit the Mulesoft.dlb. Okay. Another thing that is also interesting, is that they want to disable the automatic cache of AWS CloudFront. Okay, so they are going to be hitting every time the DLB. And another thing that they are going to use is to use the powerful rules of the CloudFront to decide to specific APIs if they want to expose them directly or if they want to whitelist them. Okay. So basically, this is a screenshot of the configuration that ADME will be using to create a CloudFront distribution that is in this case a web application firewall. Okay, in which essentially what they are saying is that they want to they sorry, I'm going to make it bigger. Okay, so basically what they do is to define which is going to be the domain name of the CloudFront distribution, the path, different parameters regarding if they want to allow all the methods or only a specific methods. Okay, and with which kind of caching they want to use. Okay, and in order to make sure that no other customer of AWS is being able to hit the Mulesoft.dlb, they are going to send a specific header, a secret header, that is going to be only that only the Mulesoft.dlb is going to be able to see that. Okay, so with this combination, typically what we are going to have is like a CloudFront distribution, a web application firewall behind the DLB. Okay, so this is just an extra level of protection. Okay. Okay. Any question on this or on the web application firewall? Okay. So just wrapping up. Okay. So as we have seen in this in this session, The idea is that to set up Cloud Hub networking, you need to follow these steps, okay? The network design, setting up the VPC, defining the outbound traffic, for example, using AWS Transit Gateway, and also finally defining the inbound traffic, no, using, for example, a DLB. And if you have an additional requirement, you can even have a web application firewall behind your DLB, okay? So, well, thank you everybody.
Yeah, any question before we move to the quiz?